Well, I was assuming a flat Earth, like to respond to what
You have to assume a
whoever
flat Earth
was
is the
speaking
only way
said.
to obtain the
I
angle.
assumed a flat Earth. Yes.
Yeah, you have
Sorry,
to.
just 1 second.
So
Just 1 second, Toymark. Just repeat that one more time.
The
I
angle.
assumed a flat Earth. Yes.
Yeah. Refraction was apparent in his viewpoint in terms of the adjustment of the geometric horizon to the apparent horizon that he's measuring to. And he's said, and we agreed on the rough formula of 7/6 R is the rate of bending of the refraction in his assumptions. That was clear. We went through that. You admitted to that, did you not?
Yeah, I did. I mean, we didn't, like you and me, we didn't disagree what refraction is. So I'm unsure why QE suddenly wants that definition.
We wouldn't disagree what refraction.
I didn't agree with you. I asked you to define what you termed refraction was in and how you were using it. Yeah.
Okay.
For its
And I said,
dislocation of the horizon.
yes, I said we're talking about
I
terrestrial
don't agree with that,
refraction.
but we were clear on our
disagreed.
understanding of what you meant.
I would like to know why he used artificial horizon. I would like to know why he addressed a bubble sextant or a Panamercury. He must know with his tremendous study in celestial navigation that it does not require a dip correction because he already assumes horizontal, level, flat. So then why does the one at sea using the Earth's horizon require dip correction? Are you telling me one can work curved, one can work flat? Two ways of doing it? No. It's height of eye. No, I'm talking, and then you could answer. To dip or not to dip? You said at the beginning, astronomical horizon, which is synonymous to sensible horizon, which is a horizontal at your eye line as a reference point to your zenith, a 90. You don't need to do dip correction when you already assume a flat baseline. Why do you have to do dip correction only and only when you use the sea horizon if it isn't to make sure it's a flat baseline giving you a 90? You're a double speaker.
I'm not. The sole reason why we need to.
Yes, you are.
Can
You've
I
been
at
caught
least
out
respond?
right now. You've been caught out.
Okay. Go on, Homer.
I mean, that was just an accusation, but let's
No, he
why...
explained it. No, it wasn't just an accusation. He explained why you're double speaking. Do you want to have him do it again?
Yeah, sure.
Well, just
go ahead,
explain the question
again.
Why do you not, Hoymar, take a dip correction with a bubble sextant or a Panamercury? Why do you not do dip correction in that instance versus at sea? Go.
Because if you have an artificial horizon, then you already have a reference that is perpendicular to vertical. You already have that true astronomical horizon that you want, that's perpendicular to your zenith. And if you are not using an artificial horizon, but you're looking at a sea, like at the visible horizon, then that will not align with your eye level. It will dip below it. And the sole reason for that is that the surface is not flat.
No. The sole reason for that is because if on a sailboat, your eye line is 12 feet above the sea level, that creates a depression angle to the horizon, and you minus height of eye to sea level to get that horizontal to become a 90, like you're sensible, like your bubble. You lose again.
So you're telling me that I'm looking at eye level. My eye level is parallel to the supposed height. where does the angle come into play?
I'm not
Which
telling you
points am I
anything.
sighting?
Celestial navigation is telling you everything. That if you use a bubble sextant, your baseline is horizontal because of the bubble and creates a perpendicular with your zenith. And when you're at sea and you're using the Earth's horizon, and because your height above the sea is 11 or 12 feet, you must bring it down to sea level to have that same horizontal and the same perpendicular happen with your zenith. It's so obvious.
Well, not to me. Perhaps you can clarify.
It's celestial
for me.
navigation. I thought you were an expert on it. I thought you knew what dip was. It's height of eye above sea level.
I do. I definitely do. You're making
well then
claims that
all
I
you're
didn't
doing
find in any manual whatsoever.
well, then
I
all
need you
you're
to
doing with your doublespeak is doublespeak, because if height of eye must go down to sea level, you just match the bubble exactly. Parallel.
That's the point. Yeah, that's the point. Due to the
Yeah,
dip
so
existing
flat
in the
Earth.
first place, we need
Flat
to
Earth,
correct
then.
for it to
No,
get
no,
a
then flat
true
Earth.
perpendicularity to zenith.
If
Right.
sea level is the parallel, right? The parallel line is straight, isn't it? So therefore, what is sea level? Is that straight or is it curved? How can you have a parallel line to a curved line? Can't.
Well, I was assuming a flat Earth, like to respond to what.
You have to assume a
whoever
flat Earth
was
is the
speaking
only way
said.
to obtain the
I
angle.
assumed a flat Earth. Yes.
Yeah, you have
Sorry,
to.
just 1 second.
So
Just 1 second, Toy Mark. Just repeat that one more time.
So I was responding to the scenario that whoever was talking to me was proposing of having a dip angle at sea on a flat plane. So I was responding to that, and I said, well, your eye level, like your horizontal plane, is parallel to the supposed water plane, right? And then somewhere you're placing a dip angle between those parallel planes. So I was wondering, how do you place an angle between those planes? Which point are you sighting on the water plane below you?
What the fuck?
What the? Listen, buddy, it's called a depression angle because the reference is the sea level, okay, horizontal to the horizon, all the way back to you, from the GP of the sun to you. And that depression angle is your height of eye above that reference plane. And so all it is getting your eyeballs on the ocean so it could match your astronomical one that you did with the bubble. It can't work two ways. It's got to all be the same.
Well, I was assuming a flat Earth.